Hello everyone and welcome to this TYS tutorial on turning effect of forces. Now before I start, I want to go through some golden rules with you as you look through this TYS. These 4 golden rules will be helpful. Alright, so number 1 is actually to locate the pivot, and pivot is usually the point at which the object can turn about. Second thing is to make sure that for every force, you go and identify what is the direction of the moments. So direction of moments can either be clockwise or anti-clockwise. Now next, sometimes they will give you masses which are in kg, and you have to change them straight away to forces, which is in newtons. Alright, because moments is force times perpendicular distance. The fourth thing is to make sure that for every question you can either apply principle of moments or they will ask you to calculate net moments, right? Principle of moments basically just means that the sum of clockwise moments is equal to the sum of anti-clockwise moments about a pivot, right? And when this happens, usually the body will be horizontal, it will be suspended, it is not rotating, alright? But at higher levels, you will learn that if a body is rotating, then it just has to continue rotating at the same speed. Okay, but this part you can ignore first. It doesn't really come out in our syllabus. Okay, let's go to question 1. So here we have a beam, 40 cm long, pivoted at one end. Okay, so straight away the pivot is mentioned and the pivot is here, this point, in blue, right? Okay, next the weight of the beam is 4 Newton. It acts 20 cm from the pivot. We have a 2 Newton weight. It acts 10 cm from the pivot. And finally, we have an upward force U that is used to keep the beam horizontal. Now here, take a look at the word horizontal. What does it mean? Horizontal, suspended. These are words that just means that the body is in equilibrium. And what does it mean by equilibrium? Well, there is no net force acting on the body. There's also no net moments acting on the body. So when you say equilibrium, both these conditions must be satisfied. Alright, I repeat, both of these conditions must be satisfied at the same time. Okay, now, since the sum of anti-clockwise moments equals to the sum of clockwise moments, since there's no net moments, so from here, just highlight this symbol to you. This means sum of. Okay, you can treat it like an inverted E. What it means is sum of, and is universally recognized, so you can use it as well. Okay, so once we have this, let's go back to our forces and decide which of these forces are clockwise and anti-clockwise. Right, so for this force, it causes the beam to move this way, turn this way. So this will be a clockwise direction. Same for this, clockwise. But for this over here, it turns the other way, so it will be anti-clockwise. Okay, so now we can start on our working. So U is anti-clockwise, so I write it below the anti-clockwise moments. Multiply by 40 cm, which is 0.4 meters, will be equals to the sum of clockwise moments, which is 2 newtons, multiplied by 0.1 meters, plus 4 newtons. Now this 4 newtons distance is not just 10 cm. The distance must always be from the force all the way to the pivot. Alright, so it's 20 cm, which is 0.2 meters. Okay, and from here you can simplify the equation. You will get U equals to 2.5 newtons. Okay, answer is C. Now this first question I've explained in greater detail. Now I'll move a bit faster. Okay, so here we have a wheelbarrow and the mass shown is 60 kg. Straight away this is in kg, so I change to newtons, which is simply 600 newtons, using W equals to mg. Alright. And then they want the size of the force, F, that is just enough to lift the loaded wheelbarrow. Okay, so just to lift the loaded wheelbarrow. So again, when I just am able to lift up the wheelbarrow, what happens is that my sum of anti-clockwise moments must be equals to my sum of clockwise moments. Okay, that's just what it means. So identify, this one will be anti-clockwise moments. Over here, it will be clockwise, right? This force due to the load will be clockwise because pivot is over here. Alright, so for anti-clockwise moments, it will just be F multiplied by the distance Distance isn't 50, it must be to the pivot. So we have 1.2 meters equals to the clockwise moments, which is over here, caused by this force, and this is 600 newtons, right? We know this to be 600 newtons. So equals to 600 multiplied by its distance from the pivot, which is 0.7. Therefore, F will simply be 35 newtons. Sorry, 350 newtons. Alright. Now next we have a pivoted window, and this window weighs 100 newtons and can be opened with a force of 30 newtons, or rather is opened with a force of 30 newtons. Here they tell us what's the resultant moment about the pivot. So since there is resultant moment, that means this time the sum of clockwise moments is not equal to the sum of clockwise moments. Sorry, the sum of clockwise moments is not equal to the sum of anti-clockwise moments, right? So we have a net moment. So what we're going to do is locate the pivot. Again, this time this is the pivot. So when I open the window, it will turn about this line, right? This line over here. And here I have two forces at play. Number one is the weight, which is 100 newtons. So this weight will cause the window to move downwards this way. This is a clockwise direction, following your clock. Right, as the minute hand moves down, this is called the clockwise direction, right? The opposite direction will be called the anti-clockwise direction. Okay, so for this force, it causes the window to move up this way about the pivot here. So this will cause an anti-clockwise direction. Alright, so let us find our clockwise and anti-clockwise moments. So our total anti-clockwise moments will simply be 30 newtons multiplied by its distance from the pivot. So its distance is this whole thing, which is 0.7 meters. And our clockwise moments will simply be 100 newtons multiplied by 0.2 meters. Alright. Now calculate each of this. You should get 21 Newton meter for anti-clockwise and 20 Newton meters for clockwise. Okay. Now resultant moment will just be the bigger one minus the smaller one. So it'll be 1 Newton meter. Right? Take note, what do you think the direction of this resultant moment should be? If I took the bigger one, which is anti-clockwise, minus the smaller one, which is clockwise, of course I'll still have anti-clockwise net moments. So answer is A, and just take note that direction is anti-clockwise. Now next, an object is designed to topple easily when hit. Okay, so it topples over easily. This tells you that stability is low. Now what should the object have so that it can topple over easily? So this is a strange object. Usually we want objects to be stable, right? So let's first talk about stability. How can we increase stability? Well, it's always the same. Number one, you can increase the base area, or just the base. And number two, you have to actually lower the center of gravity, right? So you lower the CG. These are the two things to make an object more stable. So here I want the opposite. I want an object that's unstable. So answer for this question is, I will want a small base area. I will want a high center of gravity. Alright, so high center of gravity, and then a base area that is small or narrow will be my answer. So in this case, it will be A. Last question for MCQ. A uniform plank is pivoted. Now the word uniform basically means that the CG, because it's made of the same material throughout, the CG will be at center. Okay, so if it's 1 meter long, you'll be at a 50 cm mark. Okay, now it's pivoted at midpoint, and the weight is added on either sides in the position shown. Now, since this plank is pivoted at the midpoint, its weight also acts from the middle, right? So will the weight create a moment about this pivot? If you recall to my video where I press the ruler that's balancing at its midpoint, and I press hard on it, I exert a force, it still balances. There's no rotation. So we know that all forces that act directly above the pivot will not create a moment. Okay? Now this plank is balanced by a 2 Newton upwards force. And then they want us to find the weight of X. So again, first thing, identify your pivot. Make sure you know the direction of the moments for each of the forces. Right, so for this force over here, it causes the beam to rotate this way about the pivot. This direction is known as clockwise. And for this one over here, it causes the beam to rotate this way about the pivot. So this will be anti-clockwise. And finally, for the last one, it causes the beam to rotate this way about the pivot. So this will be clockwise. Okay, so beam is balance. Again, balance means your sum of clockwise moments. I'm going to write in shorthand now. Equals to sum of anti-clockwise moments. Right, so clockwise is 4. Now you cannot just add 4 plus 2 first. Okay, you need to do each pair. So you need to pair up the force with its couple, which is the perpendicular distance. Then you add the other clockwise force multiplied by its partner, which is the perpendicular distance. Okay, so imagine them to be like a couple. They must go together. So 4 newtons multiplied by 4 meters plus 2 newtons multiplied by 2 meters. Now, is it 2 meters? 2 meters is until this point over here, right? But I need the perpendicular distance to be from the pivot to the force. So here I made a mistake. I hope you didn't make the same one. It should be plus 2 times 4. And anti-clockwise will just be x times 2. Okay, here you solve it. You can find your x to be 12 newtons. Answer D.